Well, good evening, folks. It looks as though the Flat Earth people are in a panic. And they're in a panic because their Black Swan proof is cooked. All right, so what did they do today? Ranty went off and found the biggest guns of the Flat Earth community he could find. And lo and behold, Jeran was on Ranty's show. So Ranty recorded a session with Jeran, and the purpose of this was to try and convince Jeran that there was still life left in the Black Swan. And of course, Ranty went on and on and on with complete nonsense, while in the background Jeran squeezed off a few brain farts and agreed with him from time to time, even though it was plainly obvious he didn't understand a word Ranty was saying. Okay, so let's get on with this. There's a bit to see, so this is going to be a reasonably long video, longer than I would normally expect, but I think it's important for you to get to the end of it, have a look at it, and you won't be disappointed. Okay, so where were we last time? Let's go to the board. Okay, that's just about it. Now, if you recall last time, we were talking about refraction. And I had diagrams similar to this. Over here we've got air and water, and as a ray of light comes from the observer, observer looks at a ray of light, and that ray of light is in fact bent. So an object like a fish over here will in fact look like it's over here. That's because this ray is bent. So in other words, light reflected off this fish coming up through the water is bent as it approaches the eye of the observer. And likewise to the observer thinks that he or she is looking straight ahead. In fact, they're looking at a ray of light that's bent. Now, quickly, in a gradient, in a situation where there's a gradient, for instance, the atmosphere is graded by density, a ray of light will come in, it'll bend, and then bend again. So in other words, it'll have this quite a marked bend, and as you can see, that's the gradient up here, and again it will bend. And this bending is related to the refractive index of the particular medium that it's going through. Now, in the Black Swan situation, over here, that's the curve of the Earth, and what's happening here is there is again a gradient over the surface. It's quite a hazy day. There's probably lots of water in the atmosphere, and the light bends. So again, right back here, where the rig is, this particular one, light reflects off that rig, comes back to the observer, but on its way it's bent, and then bent again, and then bent again, and the observer, for all the world, thinks they're looking straight ahead and sees the rig straight ahead. And what's happened is it's loomed up. So in fact, what's happening is, while the actual rig is down here over the curve, the bent light causes it to loom up so that it looks like, for all the world, it's up there. And similarly, anything that's beyond it, for instance, a bit more horizon, for instance over here where the horizon is, the apparent horizon is over here, that's also loomed up, and therefore it looks like that there is more water beyond the rigs. So this is what the flat earth people were saying, that it's impossible for this to happen on a spherical earth, and clearly it is possible, because this is how it happens. It happens with looming. There are other clues you'll see through the video. I'll go through that in more detail. So let me just deal with a couple of things that Ranty said over here. So Ranty says bending light causes the bottom of the objects to be obscured. Well, no, Ranty, it doesn't. If anything, it's the other way round. The bending light, which causes looming, causes more of the bottom of objects to be seen. So it's exactly opposite to what you're saying. So no, Randy, you're wrong. So Ranty, bending light, which is the looming, the bending light which causes looming, causes more of the bottom of the objects to be seen. Okay? So, in situations with little refraction, like the other photo that we've seen, that's where the items are nearly sunken into the sea beyond the horizon, the bottom of objects are obscured by a curved horizon. Again, there's not sufficient looming to bring them up, so it looks so you can see that they are beyond the horizon. Okay. The other thing is, this is not something that's covered by waves, so stop trying to pretend that waves are obscuring the rig. They are not. There's no way known that waves would be that large enough to obscure those rigs the way that you see them. Okay, you can actually see the waves at the surface. They're actually quite small, and on a very, very clear, calm day, this is still exactly the same. In other words, the rigs will still be over the curve if it's a calm day and there's not much wind and there's not much moisture in the air to cause this marked refraction and therefore the looming. Okay, so without further ado, I will let you get on with the looking at the rest of this video. Okay, everyone. So what we're looking at here is the image that the flat earth people are extremely excited about, because they think that this is their Black Swan moment, and also they think that this image alone disproves the spherical earth. So what they're saying is that this is precisely what rigs, these platforms on the flat earth would look like, and therefore it could not be spherical because it would not look like this if it was spherical. Now, let's discuss that. First of all, I agree to some extent with the flat earth people who say this is what it would look like if the earth was flat. Indeed, if the earth was flat, objects like these two platforms would be going into the distance. The further away that you got away from them, they'd continue to be just like this. The image of them would be just like this if you had a lens strong enough to look at them. There'd be no time at which they would be beyond any horizon. The horizon that you can see over there, which would be really a blurry area, that's blurry because that's the extent of the amount of resolution that you're able to make, or the camera is able to make in the distance. So this is sort of what it would look like if the earth was flat. In fact, it's pretty close, I reckon. Now, the flat earth people are saying that this cannot be on a sphere. And this is what it looks like on a flat Earth. By saying that, they acknowledge this then. Well, they acknowledge that indeed it would never look like this on a flat Earth. So what they're saying is the previous image where you see the rigs, you see the horizon beyond the rigs, beyond those platforms, that signifies what it would look like on a flat Earth. And on that point, I agree. That's what it would look like on a flat Earth. But in fact, that image only happens on the rare occasion when the atmosphere is actually dense enough and has sufficient gradient in order for light to bend. Now over here, on this particular occasion, which is almost all the time, the looming, while there is some looming, there always is some looming, the items that you see, those objects that you see, the platforms, are actually beyond that apparent horizon that you're looking at. And that is because it's a sphere. There is insufficient looming to bring them up high enough for you to be able to see both all of them, and not only that, to see some of the horizon beyond them. In this particular image, what's happening is that the looming, the light is bent from the object. So in other words, the reason that you see anything is because light reflects from it. So light reflects from the object to your eye, not the other way around. So that light is bent. As that light bends, it comes towards your eyes. When you look out to it, you have the sensation of looking straight ahead. So you think you're looking straight ahead. What appears to you to be looking straight ahead is in fact the light bending. The light bends from that object, comes to your eye, bent, and the reason that it's bent, as it's explained in Snell's law, and explained by the nature of light passing through different medium, that it will bend. We know this. This is a fact. This is what happens. We have the refractive index for various things. We know what the refractive index for dry air is. We know what it is for moist air. And we know that it's quite significant, and that would cause looming if the air had sufficient moisture in it. Okay, so once again, what you're looking at is looming. Looming doesn't just happen to the platforms. Looming happens for everything. So just as the rumpus has said so many times, everything is affected by it. The platforms are affected by looming. Any objects out there are affected by looming, and so is the horizon, or if you like, beyond the platforms, is also loomed up. So you get to see it as well. And the extent to what you'll see because of looming depends on the amount of looming that there is, and the more that you have a refractive gradient, the more looming you are likely to see, which in this particular case is reasonably severe. Now, so again, clues, have a look at the things that are meant to be straight lines. They're not straight lines. You can see that there's atmospheric effect there. And again, the looming happens to all of it. All parts of the platforms are loomed up. All of it's loomed up. So this explains why you can see the horizon in the distance. Now let's get back to this image. And again, you can see on a normal day with normal refraction, with dry air, this is what you see. You can see that both platforms in the distance are beyond this apparent horizon. Okay, you can't see them. The one on the left is missing most of it. The one on the right is missing some of its legs because it's closer to us. The other one is further away. In fact, about 3 miles different. And if you do the maths, you'll find that the 3 miles or so that separates those two rigs is explained by the curve that's between those two rigs and between the observer over here. That is the 3 mile is explained perfectly by how much of the rig you can't see. Once again, one more time, have a look at this. This is looming. This is what you would expect to see if the Earth was flat, but in fact it's looming. It's not flat. And how do we know for a fact that it is not flat, despite the fact that this looks like it ought to look like if the Earth was flat? Is because we have images like this. This has to be taken into consideration. You have a look at both of them. You have a look at this. This cannot be explained on a flat Earth. Therefore, there must be some reason why you could see the horizon on the other image. You can't have it both ways. So this most certainly is strong evidence that the Earth is a sphere. In fact, it could not be any other shape. It certainly could not be flat in order to produce this effect that you're looking at over here. Now, these images are courtesy of my friend Big Blue from Blue Marble Science. So thank you, Big Blue, for producing these. In this particular one, Big Blue was trying to appeal to flat earthers to please explain what they see here. In other words, they are two different contradicting images. So you cannot say that the Earth is flat simply because you saw the one image where there's looming, and just ignore that fact and just say that the Earth is flat. In other words, ignore 2,000 years of science, ignore all of the best minds that have ever walked on this planet, ignore all of that, ignore satellites, ignore rockets, ignore gravity, all of those things, just because you saw one image and you're intellectually too lazy to look at it in depth and work out why you are seeing what you are seeing. Nevertheless, this particular video that I've created now explains how you actually see the horizon beyond those platforms, and debunks this idea that you have your gotcha moment. As I explain later, what I suggest you do is go and look for something else, because this is not good enough. Okay, let's carry on with the video. Okay, now that you've seen this, I'm pretty sure that if you've got any common sense at all, that this is now put to bed. This Black Swan is well and truly cooked, all done and dusted. If you still want to pursue this nonsense about the Earth being flat, go find something else, because this one failed. All right, so if you like my videos, please press that subscribe button down there, and then press the like button and the or press the dislike button, whichever one you want to. If you're going to press the dislike button, do it with some force and press it twice. That's actually a good bit of advice I got today on one of my comments. Okay, you flat earth people, press it twice if you don't like it. That will really reinforce how much you dislike my video. Okay, all right. Okay, so press like or dislike. I'm going to give you a minute. Ready, set, go. Press. Okay, good. Good on you. Well done. Okay, see you next time.